In this lesson, we're going to be talking about equations as relations. By the end of this unit, you're going to be able to evaluate functions algebraically using equations and graphically. In this particular lesson, we're going to be determining the range for a function given the function, its equation, and its domain. What is a relation equation? Well, a relation equation is any equation that contains two unknown values. And those two variables are going to be representing an ordered pair, which are x and y. The equation describes a relationship, such as y equals 2x. In algebra, we're going to be looking at three different types of relationships. We're going to be talking about linear relationships. This is y equals x, where the exponent above the x is just a 1, so it's not shown there. We're going to be talking about quadratic relationships. This would be y equals x squared. This is where we get our parabola, our u shape. And then we have y equals some number to the power of x. This would be an exponential equation, and this is where we get that exponential curve. So an equation relation is an equation that contains two unknown values, which are going to be represented as an ordered pair, and the equation describes a relationship. And we're going to be looking at three different relationships: linear, quadratic, and exponential. What is a solution set? Well, a solution set are ordered pairs that make your equation, that make your function or your relation true. And your answers are going to be put in set notation. They're going to be written in braces. The domain. So when we talk about the domain for a relation, these are all of the independent variables, all of the x's, all of the x values. Remember, independent is not changing based off of something else. So our domain are our independent values. They're going to be the x values in our equation. Typically, time is going to be independent when we're talking about real-world problems. And it is also written as f of 4. So when we're talking about our domain, when we're talking about function notation, we're going to begin to shift away from x and x equals and y equals. And we're going to begin to see this function notation, f of x. Now, the entire f of x is the same thing as y. So you're going to begin to see f of x is equal to y. But if we look at the value that is on the inside, so in this particular part right here, we're looking at this value inside this 4. The 4 is in the place of the x in our function notation, in our f of x function notation here. So the value that's on the inside is representing our x. So instead of seeing x equals 4, you're going to begin to see f of 4, but it means the same thing. When we talk about our range, it is all of the dependent variables, all of our y values in this case. Time or quantity is typically a dependent variable. So where time is the independent, the quantity is going to be the dependent variable here. It's also going to be written as f of x equals 6 or y equals 6. So we're going to see f of x be written in place of y. So our function notation, the entire f of x is the same thing as y. So if we see f of x equals 6, this says y equals 6. But if we see f of 6, this is telling me that x is equal to 6. So you just kind of want to know the difference between the two. When we're listing out our domain and range for our solution set, you're going to write them in order from least to greatest. And if there's any values that are repeating, you're only going to list them one time. So let's get started. Let's study the table and find the missing y values. So here we have our table. We have 1, 3, 2, 6, 3, 9. And so we can see that as the x's are increasing by 1, as our x's increase by 1, the y's are increasing by 3. So we know that the next number in our pattern would be 12, and the next number after that would be 15. If we were going to write the equation here, we would need the slope, which would be 3 over 1, our change in our y over our change in our x. So 3 over 1, or just 3. And we would need the y-intercept, which would be when x is equal to 0. So if we were to go back in our table by 1 and back in our table by 3, we would see that the y-intercept here is 0. So when we go to write this linear relationship, and we know it's linear because there's a constant rate of change throughout this table, when we go to write this y equals mx plus b equation, it's just going to be y equals our slope, which is 3, x because the b is 0, so we wouldn't have to write that. So our equation for this one would just be y equals 3x. Find the solution set for y equals 2x plus 3 for the replacement set. So here we have a list of ordered pairs, a set of ordered pairs, and we want to know which of these ordered pairs is a part of the solution set. Now remember, in order for it to be a part of the solution set, it has to be values that make the statement true. So if I plug in my first point, -2, -1, -1, 3, and 0, 4, if I plug those into my equations, my first statement is going to be -1 equals 2 times -2 plus 3. And when we simplify that, we get the same side on both sides. Since 2 times -2 is -4, and -4 plus 3 does in fact equal -1. So this we would say is a true statement. Here we have this next one, we have -1, 3. We have 3 as our y value, -1 is our x value. If we were to substitute this, 2 times -1 would give me -2, plus 3 would give me +1. And so we know that this is not a true statement. If we plug in 0, 4, we see that that also is not a true statement. And when we plug in 9 and 3 into our equation, we see that that is a true statement. So my solution set is just going to be the two values that made my equation true. So my x values are going to be -2 and 3. Again, we're writing those from least to greatest. And my range values are going to be -1 and 9. Here we're finding the domain, we're finding the range when we're given the domain. So our domain values are -1, 0, 2, and 4. The first thing that you're going to want to do is you're going to want to change your equation, if it's not in slope-intercept form, to slope-intercept form. And so 4x plus 2y equals 10, when we change it to slope-intercept form, is y equals 5 minus 2x. And then I'm going to start plugging in, substituting in my values for my domain. So I substitute in -1, and we get out 7, and so our ordered pair would be -1, 7. When we substitute in 0, we get out 5, and so that ordered pair would be 0, 5. When we substitute in 2, we get out 1, and when we substitute in 4, we get out -3. And so our range values, in order from least to greatest, would be -3, 1, 5, and 7. Let's look at 4. So it says find the range for the given domain. So here we have an absolute value equation. So again, we're going to substitute in our values, our x values, our domain values, into the equation. Again, we're looking for y. When we substitute in that value, we get out 2, and so that first point is 0, 2. We substitute in 1, we get out 1, so 1, 1. We substitute in 2, we get out 0. And when we substitute in 3, we get out 1. And so we see that our range values here are 0, 1, and 2. Again, the 1 is repeated here, and so we do not have to write it more than once in our range. We only write it one time. So let's look at some values here. What values are associated with our x's? Well, we have domain and range. Independent values go with the domain, where the dependent values go with the range. Our y values are a part of our range, while our x values are a part of the domain. Time is a part of our domain, and quantity is a part of our range. I want you to consider what it means to write f of 4. So a function notation of f of 4 means 2, and then work on the following problem to check for your understanding. I look forward to seeing you in the next video.